In this question, we're told the continuous random variable x has probability density function f given by f of x is 4/9 of 4x minus x cubed for x between 1 and 2. F of x is equal to 0 otherwise. Part A says to determine the value of the expectation of 1 over x. So the expectation of 1 over x will be given by the integral between 1 and 2 of 1 over x multiplied by the function of x, which is 4/9 4x minus x cubed, all integrated with respect to x. To tidy this up and simplify it, I'm going to take the 4/9 outside of the integral as it is a constant, still integrating between 1 and 2, and then I'm going to divide both of these terms by x, so I get left with 4 minus x squared dx. So now integrating, I get 4/9 multiplied by 4x minus x cubed over 3 evaluated between 1 and 2. So at this point, show my substitution so that we have 4 times 2 minus 2 cubed over 3 minus 4 times 1 minus 1 cubed over 3. Okay, and at this point we've shown all the work and showed the integration, shown the substitution. All we have to do is evaluate, and if you do so carefully on your calculator you should get an answer of 20 over 27. Okay, let's look at part B. Part B says find an expression for f of x valid for x lying between 1 and 2, where f denotes the cumulative distribution function of x. So what we need to remember is that f of x, the cumulative distribution function, is given by integrating between 1 and x the probability density function with the used with the parameter t integrated with respect to t. So we're going to get that f of x is equal to the lower bound, which is 1, up to x, multiplied by, I'm going to take the 4/9 outside again, so perhaps I should have done that before, give myself a little bit of space, and the function is 4t minus t cubed integrated with respect to t. So we get 4/9, 4t, raised to the power becomes t squared, 4 divided by 2 gives me 2t squared, minus raise the power of t to the power of 3 to 4, and divide by the new power, so we get divided by 4. This is integrated between 1 and x. Now substitute my values in, so I get 4/9 multiplied by 2x squared minus x to the power of 4 over 4 minus 2 lots of 1 squared minus 1 to the power of 4 over 4. So working through this, you get 4/9 multiplied by 2x squared minus x to the power of 4 over 4, and then evaluating that last bracket, 2 minus 1/4 is 7/4. And finally, we can just expand that and just say f of x is equal to, and just expanding that bracket, we get 8/9 x squared minus 4/9, 1/9, let's just cancel that, sorry I should have cancelled the 4's top and bottom there, so I get 1/9 x to the power of 4, and then again cancelling this 4 with the bottom 4, I get minus 7/9. Okay, part 2 says hence calculate probability x lies between 1.25 and 1.75, so probability 1.25 less than or equal to x less than or equal to 1.75 is equal to the value So function, when I put 1.75 into our commutative distribution function, minus the value I get when I substitute 1.25 into our commutative distribution function. So just show my working, we get 8 over 9, 1.75 squared, minus 1/9, 1.75 to the power of 4, minus 7/9, and then this is going to be taken away, 8/9 of 1.25 squared, minus 1/9 of 1.25 to the power of 4, and minus 7/9 again. Now this can, if you're confident, be substituted straight into your calculator and evaluated in one go, and if you do so carefully, you can come up with the exact answer, 9/16. Okay, so just finishing off, it says calculate the median of x. So what I want to do for the median of x is I just want to solve that f of m is equal to 0.5. So in other words, what I want to solve is that the function, when I substitute m in, so 8/9 m squared, minus 1/9 m to the power of 4, minus 7/9 is equal to 0.5. Now what I can do here is, first of all, I can multiply both sides by 2 to get rid of this 1 at 0.5, and I can also multiply both sides by 9 to get rid of the denominators. So what we're going to get left with here, multiplying both sides by 2, I'm going to get 16m squared is equal to 16m squared minus 2m4 to the power of 4 minus 14 is equal to 9. We get 2 times 0.5 is 1 times 9 is 9. Okay, and so rearranging, I just want to add 2m to the power of 4 to both sides. I want to add 14 to both sides, and I want to subtract 16m squared to both sides, so that I get 2m to the power of 4 minus 16m squared plus 23 is equal to 0. So I'm looking to solve this quartic equation. What you hopefully may notice is that this is actually a quadratic in m squared. So this is 2m squared minus 16m squared plus 23 equal to 0. Now I'm not going to try and factorize this. 2 times 23 is 46 factors that give us 16. 2 and 23 are the only factors of 46 since they are both prime, so they're not going to add to 16. So I'm going to use the quadratic formula, and the quadratic formula is going to be used to find m squared. So we're going to get m squared is equal to minus b, so minus 16, plus or minus the square root of b squared, minus 4 times a, which is 2, times c, which is 23. All over 2 times a, which is 2 times 2. Now there's no need to show any more working than that. If I put this into my calculator carefully and evaluate this, I get two solutions. One is 6.12 and the other is 1.88. Now only one of these solutions is going to be valid. If we go back to the definition of our function, it's valid between 1 and 2 only. And I can see if I do the square root of 6.12, that's going to be greater than 2, so I can just ignore that. I'm just going to do the square root of 1.88, which comes out as 1.37 to 2 decimal places. Okay then, so let's have a look to see how you get the marks in this question. First of all, in part A, there's a method mark and answer mark for correctly substituting in and getting the integral to evaluate. There is then an answer mark for integrating correctly and an answer mark for evaluating correctly. Looking at part B now. So part B, initially there is a method mark for setting up an integral with a parameter to integrate. There is an answer mark for the correct integration, and then there is an answer mark for getting to the correct commutative distribution function. Part 2, there is an answer mark for identifying, not an answer mark, a method mark for identifying how to use the commutative distribution function. And then there is an answer mark for getting to the correct answer. And then finally, the very last part of the question, there is a method mark for setting up the equation equal to 0.5. There is an answer mark for getting to a quartic equation to solve. There is then an answer mark if you have evaluated and got values for m squared, and finally an answer mark if you have got the correct value for m, the median. Okay, well I hope you was able to follow my solution and that you understood how to mark the question.